Now we have our videos already processed and stored in different representations. Let's now see how users consume this video, how they reproduce it. And we will talk about adaptive bitrate. So, usually video is consumed via HTTP streaming, which means that for every chunk, so first, when the user wants to play a video, it just sends an HTTP GET with the name of the video. Okay? The node returns a manifest that we've seen before, and then the browser, the video plugin into the browser, reads the manifest and checks what are the segments available in the manifest, and then requests with HTTP GETs the segments one after the other. And for each segment, the browser decides at which quality, at which resolution it wants the next segment to download. Okay. So actually, in the video client, which is a plugin into the browser normally, there is a video buffer that is a piece of memory, okay, in which all the video chunks are stored. So from the one side, chunks or segments arrive from the server and they are put into the video buffer. On the other side, the player is consuming these chunks. It is reproducing them. So in the next chunk that will be reproduced is, for example, this one, and so when it is done, then all these chunks will be shifting here, and in the meanwhile other chunks will come into the buffer. So what I want to emphasize here is that there are two processes going on in parallel. One is the process of consuming the chunks, which is a constant process because each second of video is consumed each second. Okay. While on the other side we have another process that is downloading chunks from a server, and these can have different speed depending on the available bandwidth. Okay. So what we want to avoid by having a good buffer policy is these episodes of rebuffering. That is when the buffer is empty and so the player doesn't have any chunk to reproduce. Why this can happen? This is when it has not been possible to download chunks from the server. Maybe the network, there is not enough network capacity or other kinds of these problems. Okay, so we want to avoid this. Now let's take an example of different buffer status. So let's suppose we have these three buffer statuses here. Which one would you prefer? Well, let's see. The first one is not good because we have just one next chunk to reproduce. So after the player reproduces this chunk, then the buffer is empty, and so we risk there is a high risk of rebuffering. Well, the second buffer is not good as well. Why? Because the buffer is complete, so it is filled, that is good, but you see the quality of each chunk is quite small. So actually the resolution that the client is getting is small here, and I'm representing the resolution as the height of these bars. This is a pity because if we have been able to download all the chunks with no problems to fill our buffer, maybe it would have been better to download less chunks at a higher quality, since we had enough capacity. So the third buffer is kind of the best between the three, because we have enough chunks into the buffer, so we don't incur the risk of rebuffering, and also we are exploiting the available capacity by downloading high resolution chunks. So we would like an algorithm that is able to always have this kind of buffer here. And this is where adaptive bitrate streaming comes into play. Adaptive bitrate streaming is a mechanism that runs in the video client and that determines at which quality the video client should request the next chunk. Adaptive bitrate streaming is a mechanism that runs on the video client and which decides at which quality it should request the next chunk. Why it is adaptive bitrate? Because the different quality means different resolutions, and so this results in different bit rates that we need to download. And this decision is adaptive because it's taken with respect to the network conditions. Usually, if the client measures small bandwidth, it tends to download small chunks, so the low resolution. While on the contrary, when the bandwidth is enough, the resolution is higher. And you may observe it when you watch YouTube videos in a wireless network that maybe is not of good quality, or maybe there are a lot of people using the same network. Well, you will obtain a video with a low resolution, so with a low bit rate. While in other conditions, if you have a fiber connection, you may be able most of the time to have high resolution videos. So adaptive bitrate streaming is a complex mechanism, okay? Because in theory, if you want to get the best decisions possible, you should be able to predict the future network conditions. So it's not sufficient to know what is the bandwidth available now, but also what is the bandwidth available in 2 seconds, 5 seconds, in order to fill your buffer with the correct quality of chunks. And of course, we don't know the future. Network conditions keep changing second after second, and this is why adaptive bitrate is still an open research problem. Now people are trying to apply reinforcement learning techniques and other techniques, artificial intelligence techniques, etc. And this is why even if we have done a lot of progress in this field, still sometimes we experience rebuffering episodes when we watch a video.